Hey, good morning, good afternoon, good evening, wherever you are. We're excited to welcome you to another great episode of thenet.lol, where myself, Tom, and Brent today, we're going to talk with someone who you may all be familiar with if you're in the world of open source networking. We're going to talk with Andree Toonk. So Andree, welcome to thenet.lol. We're happy to have you.
Welcome to the program.
Thank you,
man.
guys. I'm excited to be here.
Excellent. So you're a networking guy. I mean, I'll let our listeners know you and I worked together at Cisco for a while, so we've intimately shared networking together with each other. So tell us about yourself and how did you get into networking? This wonderful world of networking and that.
Yeah. Let's see where to start. So, well, it depends on how far we go back, but I think I was always kind of interested in networking, but I think it kind of, I worked at a help desk for a while, which is a whole story in itself. I used to work in a supermarket. My brother used to work at the help desk, and I was like, I don't really care much about it, but he got paid more than I did. So I was like, I need to get on that help desk, right? So that's kind of like, okay, computers. So he gave me a crash course. Eventually I ended up in university, and there was this teacher that had spin up the Cisco lab, and they were doing these Cisco courses, CCNA, and I was like, wow, this is amazing, because back then it was very expensive to get all that. And I lived very close to campus, and so I did all these labs and breaking shit, and that's really how I learned a lot about it. And so then I got my first networking job at what's called the Amsterdam Internet Exchange, one of the larger internet exchanges in the world. And that really opened up my eyes into like, whoa, like this is what internet operations is. There is something behind the default route. And so that was kind of mind blowing to me. And that's really, again, set the tone, I think. Then I worked for some ISVs, mostly regional or and domestic research networks. So ISVs for research institutions and universities in the Netherlands, and so helped spin up some of the first 10 gig waves transatlantic between CERN and the US and some of the Canadian research institutions, and eventually moved to Canada, worked in a similar type job here in Vancouver at called BCNet, and then in 2012, I think, I joined this exciting startup and kind of moved from the academic world to this company is called OpenDNS, and it's a Silicon Valley thing. And I was like, wow, this is cool. And so joined a small team of 5 people, an operations team. And I was the sort of only full-time network engineer. And we did everything. Like, you got paged in the middle of the night for MySQL clusters, Hadoop clusters, and like, I learned a lot. And so eventually that became part of Cisco, and I kind of grew there. And then
I should thank you. I used OpenDNS before Cisco bought it.
I still use OpenDNS, but
I hope you do.
Yeah, but it's kind of funny. So you and your team were really. You said you were kind of the first operations people there at OpenDNS, right? So you had to bring an operational mindset into a bunch of folks who maybe didn't have that. It sounds like.
Yeah, well, I mean, the team that I was in was very operational, like that. I learned a lot from, and but we did everything: syseng, neteng, and over time, as OpenDNS grew, but also the industry matured and the whole DevOps SRE type thing happened. Luckily, we got to the point that teams took some more ownership of their services and stuff, and they were on call for that, and not just throw it over the fence. And I mean, that was certainly a industry-wide trend, and it's been great for folks that came from the operational world, because I certainly have a lot of scars to show for it, and I guess I'm proud of them, and I earned them the hard way. But generally, what I think is interesting, and I think, Kyle, you and I have certainly seen a lot, that I come at a lot of these problems that I worked on for Cisco, and network functions and all that kind of stuff, very much from an operational perspective, and less so from an architectural perspective.
Okay,
yeah, I think when you're going to be paged, it changes your motivations on things.
Perspective.
Yeah.
Can I ask you a question too, Andre? So you mentioned, so you mentioned DevOps, NetOps, it was all sort of one thing, right? Getting it done at a small company, and you came from that previous experience. One of the things, I've personally experienced is that there's a big challenge that still exists today at a lot of more traditional telcos is that it's a separation and there's a hard wall between those organizations. And did you find, you know, can you describe the good, bad, and ugly for commingling those things together?
Yeah. So I think so. I totally get that scenario, and that's certainly true in larger organizations. I guess we were lucky that we were smaller, and everybody was sitting next to each other. So we didn't yet, and now that exists, but we didn't yet have departments and groups. We were like, well, it's a small team of folks that just wanted to change the world essentially, right? For OpenDNS in this case. But I think what I really enjoyed was, even though over time we hired some more network engineers and now all of a sudden we had a network team, that we were sitting right next to the SRE people and right next to the developers. And and I think it dawned on us very early on. It's like, oh, we need to do something with GitHub or Git, right? Or we need to do CI/CD. And these were all new concepts to us. And in fact, I think you can now see, as of 2, 3 years ago, the wider network engineering community go there. And so I think we were certainly a bit early, but also realized like we don't have to reinvent all of this stuff. These guys sitting next to us have been doing this for the last 10 years. And we certainly took that opportunity to say, oh, can we borrow you for a day or an afternoon? Can you give us a crash course? Or can we even use your CI/CD system? Like, we don't have to build our own. And I really enjoyed kind of building those bridges and working with people to do that. And I think that would be, really be my recommendation to a lot of the specifically network operations teams out there. Don't go and reinvent the wheel. Like, there's people that have been doing this for a decade, and chances are they're more than willing to tell you about it. And then you can learn from their lessons instead of, spending a lot of time on your own.
Well, what's interesting, I'm seeing this sort of touches on the open source angle here, is kind of what you're saying, but a little bit further in that wall that's between those organizations is broken because, like you said, GitHub is out there. And it's a really interesting way to blow up these organizational boundaries, where, like you said, I wrote this thing and it's out there, go get it. And it's not,
Yeah.
there's not some funny interdepartmental, like I've got to throw it over the wall, and do a special handshake and, and all of that stuff, And like Brent was an operator as well. I mean, I'm sure he's told me plenty of fun stories about this too, where you've got, there's these strange, like, human problems, it's not like technology problems, right?
I feel like we're all walking sideways into Conway's Law here, right? That's
That's actually that's what it is. And I think unfortunately the network folks, I'm biased, but we often, I feel, have been the voice of reason, where some crazy engineer wanted to do something, say, hey, can you open this firewall rule? It's like, are you sure you want to open up, your Hadoop cluster to the whole world just because it's easier for you? Or if shit hits the fan, like, we always, I mean, to be honest, still in my most recent experiences, it was our teams that were very well versed in dealing under pressure when there were fire burning. Like, those are the old operations folks that have the scars to show it, that stay calm and know what to do. And like, to be honest, a lot of times
stuff, right?
Yeah, and then the fancy tools don't help you anymore.
It's just down, right? You can't freak out.
Yeah. Yeah, exactly.
When I was at BT on a Friday night, we ran out of V4 addresses for the DSL network in the United Kingdom. That was a sweaty evening.
That was a nice spreadsheet you had for IPAM there, Tom.
On the phone with Ripe and everything, you're like, holy shit, it's gonna, and you're right. If you just have step back and wait a minute, we figured this out.
So speaking of service provider disasters, I think, Andree, I started tracking you back in your BGP Mon days, and I love the stories. I remember the blogs. It's like Visa's AS just got hijacked by Tom's Lawn and Garden out of Toledo. I mean, I think that's kind of where it started, the trope of, people love to bash BGP because, simple misconfigurations can just create such a global disaster.
Yeah.
It sounds, it's interesting. You have like an XP background going into that. So like, how did you tie? When people think of BGP, they think of networking, but really, when you think of BGP in your case, it's really that security angle.
Yes. Yeah. Yeah. So actually, I just realized. So I didn't really tell that in our introduction, but so I also founded this thing called BGP Mon or BGPmon.net, which really is a BGP Mon or BGP monitoring solution, if you will. And maybe the way that started was I used to run our own network or a network in Canada, AS271, and we used to leak every now and then private ASNs, and that was due to a bug in our vendor. But the problem was we couldn't detect it on our own because you just did all the show commands on the router. You couldn't see it.
Yeah.
So you had to
And
have
you're
like
like,
an
where's this
external
traffic
viewpoint.
coming back from? Yeah.
Yeah. And so someone would email me once a week. It's like, hey, it's happening again. And I was like, man, this really sucks, right? So it's like, okay, I need to solve this. I'm embarrassed, but someone else needs to tell me I'm not doing proper hygiene. So I was like, okay, how do I do this? And then I found out about route views and write risks, that they have these public looking glasses. And I started looking into that, and I was like, oh, this is kind of shitty. You have to basically write expect scripts, and it doesn't really work. And then I realized you could download all the what they call BGP dump data, which is just dump of all the control plane traffic. And that really blew my mind. I can vividly remembering it. It was like at 8 p.m. at that night, and then I was like downloading the shit, and before I knew it, it was like 3 a.m. because I was like down the rabbit hole. Like, look at what you can find. And so then I realized, okay, I built some tools around that. And, the guy never emailed me again because when it happened, I knew that it happened and could initiate the workaround, which is basically flapping something. And then once you go through all this data, you can also see like BGP withdrawal messages. And that basically means that, the network's unreachable. And if you see a lot of them, then that means you have an outage for that prefix. And then I was like, well, you can run all kinds of analytics on that. And then you can basically say something about the reliability of an ISP or even the availability of a complete country, right? And that's, anyway, so a lot of that things, eventually that became a service. People wanted to use it. And because there was a lot of data, I couldn't really share the script. So I built a portal around it, which was my first journey into provisioning a portal or building some web development.
That's really cool because before that, like I worked on IPFix, NetFlow, even before it was called NetFlow at Cisco, it was called BGP Next Hub. And George Swallow basically invented this stuff way back when. And we were doing what you're describing, but largely kind of by hand. And, this is 20 years ago, right? We were noticing certain weird things. Like when like you're saying, some things get withdrawn. What's going on here? Because now I can't get anywhere. And really like building those correlation rules around that stuff and automating that really has improved network stability. I mean, you can't just rely on BGP itself. That's the sort of magic I learned as a network operator. It's not like a set and it magically auto does itself. You know what I mean?
Certainly not. Yeah, and so I think like a lot of people started using this. Eventually, obviously, Brent and Tommy, I think you guys used that. This is great, and at some point it became too popular, and my personal server that did a whole bunch of email for the family and stuff as well kind of ran out of resources, and there were some power users out there. So eventually it became a commercial version, like a free one and a commercial one. And anyways, it's like you were saying, Brent, lots of crazy stuff. And to me, this is really what blows my mind, because the more I dug into it, the more I was like in denial, like this can't be true. We cannot have built a multi-trillion-dollar economy or the thing, the internet, that keeps the world alive today. Like we can do remote teaching or remote doctor's appointments and whatever. And it's built on this thing that is just like, you can't trust it. And the more I looked into it, every day I would find something that like I would pull my hair out. It's like, this can't be true. And so it's very fascinating.
Seen it 20 years ago.
Well, yeah, probably. I guess
That's
the only
why
difference now
don't have
is
hair
like
to pull out anymore.
There's a lot of dependencies on it, and what fascinates me is
Yeah.
that there's only a very few people actually looking at this actively. Luckily,
And
things like
actually understand
RPPI,
it in detail. That's the thing.
yeah, and I think it's getting better now. And I'd like to think that we contributed to that to some degree, mostly by creating awareness, like
Really. Well,
creating
visibility, right?
blogs.
If you can't
Yeah,
measure it, it's this is like with electronics and a lot of other stuff. You can't measure it. What is it, magic? You know?
yeah,
So
yeah.
you're right.
Yeah, that's an
Yeah.
interesting
So
point.
creating some of that awareness, having people monitor their own networks, highlighting some of the strange or large scale events and kind of explaining, yeah, like this is what's happening. And, hopefully that will make it better.
Yeah, I love the looking glass um, kind of being your inspiration. I mean, I think anybody in networking's gone and looked at a looking glass or
Yeah. Well, that's like step
first time
one
they
of,
saw it, like,
of
oh my God,
what
wow, this
Andre's
is
been doing, right?
transparency. Yeah.
Yeah.
I couldn't get passwords on the Edge router until I'd been, at least breaking stuff for a year or two. Now I've got to
Sign
figure
something
out
in,
this
Yeah.
in
a
blood,
million
right? And
line
offering
prefix
up your
list.
first kid. Yeah.
Yeah, right.
Oh man.
Well, but
So
but
Andree,
the thing,
yeah, go
the
ahead,
point
Tom.
is that it's really fragile in that it's the complexity of it's not just BGP, it's the complexity with how BGP mates with the IGP, right? And you're leaking routes and controlling that, and every network I've ever looked at, that's really different. You can take your CCIE recipes or whatever, but people do have a different situation, and
No, I agree. And
and
our
it's
vendors certainly haven't made it easy for us either, right? Like it's very easy to make
yes,
mistakes, which is really 90% of the BGP hijacks or even large scale outages like that are accidents or just typos. And
bad behavior,
that
yeah.
certainly doesn't help.
It's the
There should be
complexity
like
thing
a
again.
warning,
Yeah.
Yeah.
redistribute all. Are you sure? Are you
Are
really
you
sure?
sure?
Are you sure? Are you really sure?
Somebody did that
Yeah.
when I was at
Oh,
Cisco once
yeah,
internally. It was hilarious. From one of the labs.
I believe that.
Redistribute all back from the lab, and all of a sudden, like, nothing worked.
Nothing worked.
That sounds like the same as misconfiguring your traffic generator in the lab, pointing to the right IP, the wrong
Totally.
IP.
The internet is not
Fun
towards the lab.
times.
It's the
That's
other way.
right. It's the other way.
Oops.
Oh my
Yeah.
goodness. Oh man.
That's
So
really
Andree, I
funny.
wanted to switch gears a little bit because you've been up to a lot of different things. So recently, for people who follow you on Twitter, you've been doing a lot of blogging about various Linux data planes and performance testing. Some of this on bare metal, some of it in Amazon AWS. So can you tell us a little bit about some of the fun things that you've been doing there?
Yeah, certainly a lot of fun, and also a lot of work. So yeah, so I've been trying to explore. So Kyle and I, we've worked a lot on. So the last few years have been a lot around virtual network functions and how can you deliver those as a service essentially, right? And so one of the things I've looked at is data plane options. So as we are now virtualizing these network functions or even virtual appliances, the problem typically becomes how fast can you do network processing? And one of the things coming mostly from an operational background, like I read about things like DPDK or VPP or XCP and eBPF, and it sounded all super interesting, and I kind of knew what it was, but didn't really know what it was, right? Like I could give you like a one paragraph overview from the blogs that I remembered. And, maybe a little sidetrack, I felt like we often did get the questions like, hey, what is this? Like if there's network engineers listening here and you feel like you have sort of this cognitive overload, I think that's okay because as we have grown our worlds, you are expected, whether that's fair or not, to know a lot. So it started with just some OSPF and BGP and VLANs, and that was it. And then things like OpenStack came around, and then all of a sudden you have to know everything about hypervisor networking and all that kind of stuff, and the various tunneling protocols. And then VMware had their own version, and then Kubernetes came along, and then you need to know that. And then now we want faster networking. And so I've been in this world, and specifically the one around faster data planes I wanted to know more about, and I kind of set out on this journey to like, hey, let's go and figure this out. So I wrote this 4-part blog series on Toonk.io, which is my blog, and started out with first I needed a packet generator, and I don't have an Ixia in Amazon or whatever, some other, so I needed a reliable software-based one. So there's a blog around that. Then I measured the Linux kind of kernel, like how fast can it do networking as a router, just forwarding packets. And I would throw sort of 210 gig NICs at it, and both NICs would be sending and receiving at full rate, which is like 28 million, maybe times 2, 48 million packets per second or so, or whatever that number is. And yeah, with Linux, sort of this TLDR is like I needed about 30 cores to do that. So if you want to have a 10 gig router, yeah. And I was like, okay, cool. Now I have a baseline, right? And that was on bare metal, like not even on the with an hypervisor. And then yeah, explored DPDK. I've heard of DPDK, but it's this Intel thing, but I didn't really have any operational experience with it. And so that took me a few weeks, and I learned about DPDK and VPP as a forwarding engine between that. So certainly learned a lot. The results are amazing. Like what I needed for Linux, 30 cores with VPP and DPDK, I only needed 3 cores, which is like mind blown, right? Like it leaves a lot more budget to actually do whatever this virtual network function is supposed to do: packet inspection, rewriting, all that kind of stuff. But I also learned that it is highly specialized. So you lose.
I was just going to ask you, like what you just described, isn't that actually pretty complex? Setting that up, that's a lot of moving parts in that recipe. And this is actually one of the things that really bothers me about not just Linux networking, hypervisor networking, or container networking today. Is it's remember we were talking about this with Casado the other day, like to a networking person, they tend towards those kinds of solutions. And a lot of what we've done is we've replicated the same stuff, like you said, in bare metal up here and then up here and then over here. And now you've got to configure and twiddle with all of these different things to make it harmonious and work right. And that's not easy. That's a lot harder than the BGP stuff we were talking about earlier, right?
Yeah, it's a huge time investment, and so I think part of this why I wanted to write it down was really document my journey and share that with others and try and make it easier if you wanted to get some. Because even if you read the blog, hopefully it's more like a getting started thing into some scripts that you can download. So you literally don't have to spend the same amount of weeks that I had to do to figure out. Like DPDK, it's super fast and awesome, and VPP, but it's the learning curve is incredibly steep. And it's built by experts in data plane networking, but it's not built for ease of use.
Also server networking too, which is a little different than, I've built routers, like some of these guys, different.
Well, the other thing is different. Like your blog was focused on performance. It would be interesting to see you do a blog around operational items as well, right? Because, there's a trade-off in some of that as well. How easy are these things to operate? But I know that you were focused on that performance aspect. So
yeah, and I certainly think so. The last blog was then about XDP and eBPF, which for I don't know if your listeners are anything like me. Like I've heard about this. I think that strikes a very nice balance between sort of traditional kernel networking, which is super easy or easy to use if you have some experience, and feature rich but slow, and then XDP. And DPDK is all the way super fast. Actually, sits a little bit in the middle. You get the speed advantage. It might not be as fast, but certainly for the same test, I needed 5 cores. With VPP, I needed 3, the kernel 30. So still very much gives me a lot of budget to work with. And you don't lose the NIC. You can still punt easily to the kernel. You can use the kernel lookup tables. And I found that stroke a very nice balance between those two things. And so, that's really the journey. Like, okay, Linux networking, it's slow. I could not articulate how slow. So, because that was always easy to say, right? So I was like, I want to know how slow is slow. And now I had a better idea of, okay, with DPDK, you can go this fast, XP this. These are the pros and cons. And then I was like, okay, cool. I can do very fast networking. Okay, where do I do this, right? And then last year or so, 2 years ago, AWS released 100 gig instances. And it was like, boom, that's it, right? Now you can build really
Let's
fast
try
network
this out.
functions. Let's try this out. And, quickly learned like anything AWS or general public clouds, like lots of limitations, which is fair. They need to put in limitations to assure guarantees for, noisy neighbors and stuff. But yeah, the 100 gig it was 100
That's
gig.
the operations thing again, too. It's like there's always a trade-off. You can go maximum performance, but in any one of these iterations, maximum performance offers maximum complexity also. It's not, and maximum inflexibility, right? DPDK is very specific, right? And it's interesting, like we're talking with Thomas Graf in a couple of weeks about eBPF and its potential to really be the next sort of evolution in Linux networking. And one of the things that the problems today, when you compare AFXDP and eBPF specifically, is the hardware offload is just not, well, first of all, it's not very mature, right? It's getting there. But then the programming model, right? Like these are little snippets of programs where you have to basically translate functionality, and we got to learn a new way to do it. But once we figure that out, is that flexibility really the key here, right? And then operationally flexibility, like you're saying, like you mentioned earlier, like some guy wants you to open some firewall rules. Well, now you can do it software programmatically at the server level, right? For a certain workload, for a certain time, you know what I mean? And operationally, I can see this being more intuitive than I've got to call the department that runs the edge router to reprogram the firewall. You know what I mean?
Yeah, and then create a ticket and it gets into a queue.
Ticket.
I did. So I agree with you, Tom. But I would argue that this minimalist programming environment, like for XDP in particular, is a good thing. Actually, I think it forces you to write concise, very concise programs that are well understood. And I at least
well tested
I've done a bunch of XDP work over the last 6-9 months, and I found that you end up with a very, very tight, well-written program, and that by nature of it being simple, I would say it's easy to performance analyze as well. Like Andree, I know like your work, for example, I know you were taking advantage of the fact that with XDP you can do like fib lookups, right? So you can use the Linux routing table, which is great. Mm-hmm. But if you do that on like a per packet, if you're doing that per packet, that's expensive because you are calling back in to the kernel, right? And so at least what I found was like, and it's super simple to see this, you make that initial call to get that route, and then you cache it in like you're in a map somewhere, and like with another 10x performance boost. It's these types of, because it's so simple, the programs are simple. It's pretty quick to catch these things.
Yeah, debugging it is probably easier. Too, once you understand the structure. Yeah, because you go, oh, it's that little snippet that's intercepting this thing and is caching that thing, and
all of this is definitely the future, because you look even with what the kernel folks are doing at the socket layer with eBPF, which we didn't touch on, but some of the exciting stuff going on there with the sock map and the sock hash interfaces. I mean, in another 2 years, basically no one's going to be talking about proxies that aren't eBPF proxies, because the capability of managing the proxies by opening the sockets in a user space program and then offloading the proxying into the kernel, that's a game changer. And I don't think many people are aware that this is happening and that it's coming, but it's going to blow people's minds. Cilium does make use of a lot of this technology under the covers, but I think this technology has a chance to really change just the broader Linux networking industry. It's going to be really fun in a few years.
Yeah, it has tons of potential.
It's really good. So Andree, along with data planes, another thing that you and I have spent a lot of time on, which actually we were supposed to present at the Open Networking Summit on this year, and we, for a variety of COVID related reasons, we never did. But we've spent a lot of time talking about key value networking, and I feel like we talked about data planes, and you and I have this concept of key value networking as the control plane. Can you kind of walk us through your thinking on that?
Yeah. So maybe like the picture is like, okay, now that we have a good idea of what we can do in the data plane, now we have to solve the control plane. And Kyle, you and I have certainly worked on that a lot. And I think a lot of, we call it key value networking, but to expand on that is, I think it's all grounded in taking, building on the separation of control plane and data plane, right? Like this has been around for a while. And so can we do that in cloud native environments as well? And so it really comes from the challenges around, at least back then, existing virtual network functions, which really often were just virtual appliances. They weren't virtual network functions in cloud native environments. They were like, oh, here's a, whatever firewall vendor you are, I packaged it up, go and run it. Yeah. But it really doesn't live up to what I think is the promise of virtual network functions, because it's really just a lift and shift from bare metal to virtual appliances, and we didn't take the opportunity to rethink.
It's right there in the name. It's the appliance. It's not the function.
Exactly. The virtual network functions are pets still, right? And we still have the problem for redundancy where we do 1 + 1 or n + n, the same as we do with bare metal devices, and a lack of APIs. So that's kind of sort of the baseline. So what if we can do virtual network functions at large scale in cloud native environments? And so the one thing that, when we were thinking about this is like, well, what we really need is to extract or use these fast data plane components that we just talked about and consider them as line cards or ports. And now we need a routing engine that traditionally sits as a separate blade. And this routing engine can be a separate cluster or deployment or whatever somewhere else. And so a very simple example is if you want to virtualize a normal router, which is the basic thing. So then every port, which is normally on a normal router, is now a VM. So maybe I have 10 of them. And so if you have normally 10 VMs, then all of them would run BGP and they have their own control plane. And so we said, no, I don't want that. I want one BGP daemon that could be clustered, but it's one logical thing, and then 10 packet forwarders. And now what does the control plane normally do? Well, it produces a FIP. It does a bunch of calculations, produces a FIP. And that's what we said, well, let's put that into these modern key value stores and have the data plane nodes pull from that, either cache it, sync it, just-in-time lookups, or whatever. And so Kyle and I, we played a lot with, various ones. So a router is one example. We spent more than a year on an IPsec version of this as well.
Oh, yeah.
Building in cloud native environments, this is interesting. So you build these workers, and workers are typically ephemeral, right? And so like you throw and grow or you shrink and grow the worker pool, which means that nodes come and go. And so how do you do that? Well, typically you do draining or whatever. But the problem, which works great for DNS or HTTP because they're very short-lived. Well, IPsec is like the worst, because IPsec sessions to branches and data centers are up for days to weeks to months. So you can't drain them, right? And so we came up with a mechanism where we basically had ephemeral workers, and a session can land on any node, and it just does just-in-time lookups into some kind of key value store and gets that. And so we talked about an example for routers, IPsec. We also looked at, for example, NAT, which is the opposite problem, where it's very ephemeral. But the number of lookups that you will need to do are very high, millions of sessions per second. And so I think we really played along this horizontal line to like, how far can we take this? And, I know work is still happening there, but I think that's the future of virtual network functions in cloud native environments, where you have fast data planes, either using DPDK or XDP, and this control plane, data plane separation. And then the result of the control plane needs to go into some kind of what I've called cloud memory, right? And you need to be able to access that very quickly. And, with the rise of, distributed clusters and Kubernetes and all that, there's lots of key value stores or other distributed databases that allow you to make that happen. And the question is really, how fast can you do that, and how extreme can you take it?
It's interesting, going back to your analogy of cattle versus pets, and overlaying that on what you're describing. There are schemes that are out there today which do what you're describing, but rather than creating these ephemeral nuggets like you're talking about, they're actual instances of the VR, which is not the point, right? Again, we're back to they're a bunch of the basically appliances, and managing them like a virtual router with like a whole netconfig thing or whatever, right? And rather than like a quick, simple API a REST call that says, do this or interrogate, their little piece of the routing table or whatever. And this is an iteration that's not happened yet that you just described. Like what you're describing is really the next iteration of these things, like a wall of virtual ports controlled by a control plane, a couple of control plane instances. We did this at my last gig, and it worked quite well. But when it came down to managing it, operators were like, "This is not going to be fun," because what you've effectively done is given me N more routers to manage in my configuration and provisioning and monitoring systems, and it's crazy.
I think this is part of the problem. I agree. I think so. What Andree, like what we've done a lot with this KV networking, like if we tried to make a product that we were trying to sell, as a vendor to someone, I think that would be very challenging. I think we were lucky in that we had no product to sell. We were enabling the product, right? So that's kind of what, at least I think, why we had some success with this as well, because we were the ones building and operating these platforms.
Yeah, it was delivered as a service, and we had highly skilled operational teams that helped, and very importantly, that also helped build the product. So it wasn't something, hey, we built this pretty complex thing, and it's complex, but we can justify the complexity because it will give us like a superior scale and uptime and all that kind of stuff. But it comes at a certain complexity. Like, this is not for everyone. And this works because, it's going to serve thousands of customers, and we own and operate it. This is not something you would put on a CD-ROM and give to a customer. I think that would be, because there's a lot of
having a small enterprise use or something, right? That's what I'm getting at. These are like massive scale things.
Yeah.
And we've certainly worked on parts where I think, at least I certainly admitted, like, okay, we made this work, but maybe we went overboard, and it's too complicated. Right? Like, it's like coming from that operational background. If I get paged in the middle of the night, do I know what to do? It's like, well, there's so many moving parts now with these distributed systems. You have to properly instrument them, and I think. It's been a very interesting journey to see sort of the spectrum. But I also learned that just because you can do it doesn't mean you should, or maybe just the sort of ecosystem isn't mature enough to go all the way there because it's just too complex. There's too many failure cases, and it's too hard to troubleshoot it in the middle of the night.
Yeah. Well, that kind of ties back to your earlier point, right? So we're stacking all this technical debt onto the next generation of operators. So you have to learn the past 20 years of networking, but now you also have to understand modern day DevOps, systems engineering, and by the way, you need to learn how to code in order to use a data plane, right? I don't know. So I guess I tend to pound the table quite a bit on simplicity, and unless you can make your black magic usable, it's a dead product.
Absolutely.
Or you get some kind of like wide adoption in the community where no matter how complex it is, it's going to be adopted, e.g. Kubernetes, etc. I think there are exceptions, but it's interesting.
Yeah, I'm certainly very empathetic to the complexity of things, and what you said. I have felt that firsthand and saw it in the teams that I worked with, and maybe I'm biased, but I think the network teams have always been traditionally understaffed. Like, it was just a cost. It wasn't really seen as an enabler. I think luckily, this is changing a lot, and certainly in the environments I've worked in. But as a result, they were understaffed. Things are always slow. People don't understand the domain. Like, they tend to understand maybe the system types things, and why don't you just automate it? Well, because my vendors make it very hard to automate anything, right? Because there's no standard automation. And only now in network engineering do we see a trend towards some kind of standardized automation. And so I have a lot of empathy for
operations again.
So I have a lot of empathy for those teams where they have to keep the internet working as it is with all the interrupts. Like, this is broken. I don't know what happened. It must be the network. And 9 out of 10, we call this the mean time to innocence. 9 out of 10, it's not the network, but you have to prove your innocence. And all this slows the teams down. Oh, and by the way, in the meantime, you also need to learn Kubernetes, and you need to learn this, and you need to learn this. It's just this huge overload. And to be a successful network engineer, and luckily I've met many of them, they tend to be incredibly smart and incredibly motivated because you have to, right? Because
And multitasking, for which you
you're being
described,
asked
right?
a lot. Multitasking while learning about new technologies, while performing under pressure. Yeah, man, network engineers out there, you guys rock.
Yeah. Mean time to innocence. That's beautiful. I
That
always
is
Quote of the
did
day.
guilty
That
until
is
proven innocent, but that's taking it to the next level.
I like
But
it.
that is how these calls go, right? I mean,
Absolutely.
I've been on them recently, where you get on and the operator sets up the call and all the vendors get on the call and they're like, all right, which one of you is going to hit the firing squad today? Confessions
Yeah.
now, please,
Who's gonna read the TCP dump?
Oh
Yeah.
goodness,
Yeah.
goodness,
And
not a
so,
PCAP
but
file.
I guess it's certainly very important when we build those solutions to keep that in mind and embrace new technologies. Some of these new technologies certainly make it easier, or they're now being packaged in such a way that it's easier to use. And I think the future of virtual networking is very bright with the data plane technologies out there, with the more modern control plane things. And I think there's certainly for your listeners like network engineers or systems engineers out there some interesting niches to carve out there and do something cool. I mean, even though it's challenging, I think, and if you don't have enough time, there's a ton of opportunity to. So the network world has been kind of boring, in my opinion, for the last 10 years or so. And a few years ago, this changed with the rise of virtual networking and like the ability to start rethinking some of this. But it's challenging. A lot of people are kind of grounded still in the old world. And even in some of my experiences, like, oh, we need to deliver, I don't know, X as a service, firewall, IDS, NAT, whatever. Why don't we just take an appliance and automate it around that? And it's like, you're just missing the whole point. Like you have an opportunity now. If you really want to scale this to millions of people, which you say you want, then we have to rethink it. But it comes with an upfront investment, and we have to stop cutting corners everywhere.
Yeah.
So I really like the key value control plane networking you guys are talking about. I think that's a great way to put it, to kind of help networking people transition past, the networking control planes are only OSPF, BGP, et cetera. I think when I started getting into Docker networking, I definitely changed my thoughts on the only way to distribute state in a network is BGP. I think that's, etcd, console, these things are control planes as well. They're even more flexible in a lot of ways and can be
more modern,
yeah,
right? And it gives you a lot for free.
Yeah.
Yeah,
So
like,
you look at some of these things,
RDB,
all of them,
yeah.
Redis
A simple
included,
way
they
of
all
putting
are-
it, though. I really like that.
Yeah. So I think that's the idea. Like, you have all these control planes, they do complicated work, but the output of that is a FIP or a state table, a NAT translation table, and you just redistribute that using Redis or console or whatever is best for the job, right? And maybe one more thing around the operational things, and this is kind of fun. Akal and I worked on that a lot. And coming from OpenDNS, we used to do a lot of Anycast, and so we tried to take some of those things as also kind of explore how far can you take that? The traditional Anycast is typically just used for DNS, and we were like, well, can you take it to something else? And one of the reasons why I was such
like
a
multicast for a lot of people. It's a step below black magic, right? They don't quite understand how it works, right?
Yeah, so maybe that. So Anycast, like, the same IP address lives on many places in the world, which is really great for even for virtual network approaches. Like, I want to set up an IPsec session. Well, so you better make sure that endpoint is always alive, which comes with its challenges. But what if you have an issue in that availability zone or in that region or in that data center? You're still kind of screwed. But what if you could just magically move that IP address to another data center? You just announce it somewhere else now. And if you then combine something like that with, hey, that distributed key value store brand that we just talked about, can I also make that available there? Boom. Now all of a sudden you move the data plane and the control plane around. And with these new technologies, you can do these kinds of things. And obviously you can hear some of the passion. That's what I'm really curious and interested about. Like, how far can you push that? And realizing that sometimes it's too far, you've introduced too much complexity, but also sometimes you might be onto something, and it's just being creative. And from an operational perspective, the Anycast model has always been really good for us because, hey, this data center in this availability zone is misbehaving. We do not understand what's going on. We're in an outage thing. Just take it out of rotation and have traffic go somewhere else. And you leave it the state as it is. So now you can investigate it at your own pace and yada, yada, yada. But the outage is over. And I think those are really nice models to play with.
Yeah, well, Andree, there's been a lot of stuff here. I think we're kind of winding up to the end, but I wanted to give you, and by the way, you're involved in so many different things that I feel like we could have done 2 of these podcasts with you. But I wanted to give you, maybe you could, as a closing note, you could just give everyone a quick teaser on mysocket.io, which is, yet another kind of cool thing that you just have been working on for the last few months.
Yeah. So yeah, I've kind of the virtual network functions and the data plane are a little bit on pause. So I started a new project maybe to learn more about, become a better DevOps type person and learn more about all the AWS technologies out there and kind of do it the proper way. So what is mysocket.io is a project that wraps that around. It's basically a global cloud delivered load balancer. Think of it as that. So let's say you have a service running in your data center or in AWS or even on your laptop. You want to make that globally available, maybe a multi-data center, multi-region, multi-cloud. So the first thing you do is you create a global endpoint, a load balancer endpoint, which we call a socket, which is basically an HTTPS service or a TCP or TLS port, and it gets a name. And then you register origins. It could be one origin. It could be many of them. It could be something on your laptop behind firewalls or NATs. And then you set up a secure tunnel from the origin to our Anycasted network. So this is all Anycasted as well. So the cool thing is that I think it's a global load balancer, but normally a load balancer reaches out to the origin. So the origin still needs to be publicly available. In this case, the origin reaches out over a secure tunnel. And then we stitch that together, which means that the origin can be behind NAT or whatever. And you can have many of them, and then we can do load balancing. We're just finishing up a Kubernetes sort of a service for this as well. So you have a Kubernetes service. You can just set an annotation, mysocket enabled, and then that service is globally available via our Anycasted load balancer. So this, maybe to an earlier point, always trying to learn, have a fun idea, and combine it with new things is my journey into learning more about Kubernetes. Now think of that of putting application on top of it. So anyways, that's my latest project. If you're interested, check out my blog or mysocket.io if you're interested in global load balancing technologies.
Well, this was great. Lots of stuff going on. So I encourage everyone to go and check Andree out on Twitter. Reach out to him there if you have questions. And Andree, thanks a lot for spending some time with us and having this discussion. It was fun to have you on.
Thank you, man. This is fantastic.
Yeah, appreciate it.
Yeah.
Awesome. It was fun to be here.
Excellent.
Thank you, and hopefully we can have you back again.
Yeah.
Awesome.